Hello, this is Mrs. Taylor, and I'm going to go through a few examples of problems where you're comparing linear relationships. These questions are great examples of higher order thinking skills and how we're going to take everything we've done for the last week and put it all together. So our first question looks like this. Two functions are shown, f of x and g of x. The function g of x is shown in the coordinate grid. The function f of x includes the points in the table. So I'm going to label this g of x is shown in the coordinate grid. I'm going to label this as g. Forgive the handwriting. Oh, that was supposed to be an x. G of x. And then, of course, this is f of x. So I'm going to just put a little dot here so that I remember that the graph is g of x, the table is f of x. It says, what is the sum of the y values of the y-intercepts for g of x and f of x? So sum means to add. So we're going to add the y-intercepts of these two functions. But first I need to find the y-intercepts. So the y-intercept is where a line crosses the y-axis. And so when I look at this graph, I see that this line crosses the y-axis here, which is at a y value of 2. So the y-intercept of g of x is 2. And then in the table, I don't have a visual. I can make a visual. I can plot these points on a graph if I want. So if I choose to do that, I could plot the points -2, 1, -1, 3, and so on. On a graph, I would start at the origin, and I would say, okay, -2, 1 would be to the left 2 and up 1. That's this point. And then -1, 3, 2, 3. And then I have 2 and 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Jumps way up here. So I could try to connect those and find my y-intercept. Or I could use what I know about rise over run slope. So from this point to this point, I rose 2. So up 2 and then to the right 1. So I would just continue that pattern. Up 2 to the right 1. Up 2 to the right 1. Up 2 to the right 1. Now I can see visually the y-intercept is here, which is 1, 2, 3, 4, 5. Now there's another way to do this. In a linear relationship, change is constant. So what that means for a table is the x value and the y value are related. It's called slope. And the change in y, which would be 2, over the change in x, which would be 1, is your slope, 2 over 1. And in a table, I know my y-intercept is where x is 0. Well, x is 0 between this entry of -1 and this entry of +2. If I break my table apart and fill in some missing values, so instead of jumping from -1 to 2, I want to continue to change the x value by 1 unit. The next entry would be x is 0. And then because this is a linear relationship, I know that the y value would then change by 2. So 3 plus 2 is 5. And so knowing that the y-intercept is where x is 0, if I can find my 0 term, my term where x is 0, then I know I found the y-intercept. So I could find the y-intercept from my table by filling in missing values. Either way, the y-intercept is 5, whether I plotted the points or I used the table. But that's not all the work I have to do, because it also asked for the sum of the y-intercepts. So that means I have to add. So the sum of the y-intercepts would be 2 plus 5, which would be 7. So that's how you would approach this problem. Now let's look at the same two functions. But this time, instead of adding the y-intercepts together, we're going to add the slopes together. So I need to approach this differently, because the slope is the rate of change. Change in y over change in x, rise over run. If I look at my graph, which remember was g of x, this I'm going to type it because it was really messy last time. I want to know the rise over run. And I can do this two ways. I can either find some points, find their coordinates, and use the slope formula. So I would have, and remember when you do this you want to pick whole number coordinates, non-decimal coordinates. So I have a point here and a point here. So I could find the coordinates of those points. This point would be 0, 2, 0, 2, and this point would be 4, 0. And I could plug those into my slope formula, y2 minus y1 over x2 minus x1. I would do 2 minus 0, subtracting my y's, 0 minus 4, subtracting my x's. And once I simplified that, 2 minus 0 is 2, 0 minus 4 is negative 4. Reduce that and you get negative 1/2. So my slope for g of x, the rate of change, rise over run, is negative 1/2. The other way I could do this is by starting at one point and counting my rise over run. So I could start on this point to the left and I would go down 2 to the right 4. So that would be negative 2 over 4. Or if I chose to go from the right point, I would go up 2 and to the left 4. So this time it would be a positive 2 and then a negative 4. But it didn't really matter. However I put it together, I would still get negative 1/2 once I reduced everything down. When you are given a table and you have to find the slope, you need the change in y over the change in x. So you just pick a set of points, a pair of pairs, coordinate pairs. And so the change in y here is 1 to 3, which would be 2. And the change in x here would be negative 2 to negative 1, which would be a change of 1. And so the change in y over the change in x would give me the slope of this table, which would just be 2. So what's the sum of the slopes? I need to add 2 plus negative 1/2. Now, if you forgot your fraction rules, it's not a big deal. You can use your calculator to add this together. 2 plus negative 1/2, I would press 2 plus, and in your calculator, fractions need to go in parentheses so your calculator knows that all of that together is a fraction. And negative 1/2 would be negative 1 divided by 2. Close off your parentheses and then just hit enter. Your calculator will give you the answer in decimal form. So to convert it to a fraction, you hit the math button. You want to convert to a fraction, which is option 1, so you press enter. Press enter again, it'll convert it to a fraction for you. So 2 plus negative 1/2 is 3 over 2. And that would be the sum of the slopes. So that's just one example of how you can use everything we've done with these forms of linear equations, put it all together to compare linear relationships.